to the Vintage Computer Festival. And you happen to be in the noontime session, so thank you for coming instead of eating lunch. I'm really excited about speaking here. One, it's helping out Michelle and Steve, and I want to thank Steve and Michelle for putting on this great event. It's been really well attended, and it's pretty exciting for them, and I'm happy to be a part of this. While I'm not in the game field, which is what most of those guys are doing over there in the exhibit room, I'm here to give a little bit of history on IBM and what role it played in the previous century on how we have the technology we have today. So once again, my name is Dan Watt. I'm 70 years old, so I'm an old guy, I admit that. And today, again, like I said, I'll be sharing my insights to the computing industry. Just a quick overview. I started with IBM when I was 20 years of age in 1973. And at that time, IBM designed and built primarily equipment for commercial application. That would be including businesses, of course, and office work, so everything from copiers and typewriters to mainframes, tape drives, disk drives, etc. And that's, of course, when the things were the size of double-walled refrigerators. Anyhow, so prior to the year 2000, I guess I should have had that on earlier, sorry about that. That's a little background on who I am and who I've worked for and what I used to be. I used to be a cyclist, a musician, different things before I had this terrible accident in an automobile a couple of years ago. So now I'm a paraplegic in a wheelchair. But prior to the year 2000, IT was probably known as data processing. I know they don't use that word anymore, but over my career, I've serviced a variety of equipment in the data processing environments, working in areas such as aerospace, the petroleum engineering fields, insurance, healthcare, banking, grocery, and retail. The data centers supporting these businesses typically operated 24/7, so they didn't close down after most people went home at 5. And so besides our normal 40-hour a week, I was on call 24/7 for any emergency call-outs, which in those days happened quite regularly. After retiring from IBM, I ended up going to work for Kaiser Permanente. I'd been with IBM 43 years, and when I retired, one of my customers wanted me back. So they gave me a call, asked me to come to work for them and help manage 2 of their data centers. One was in Corona and one was in Irvine. My focus today will be on the technologies which IBM developed and marketed, essentially creating the computer industry and the time-saving tools that we have today. I suspect, and looking at the crowd out here, there might be a few, that anybody that was born after 1999 has very little connection with a company known as International Business Machines. It's not necessarily a common word like it might have been back in the 60s and 70s. Ironically, without the innovation, inventions, and technology developments that came from IBM engineers through the last 50 years of the previous century, we would not have our little flat screen telephones in front of us that we spend so many hours of a day on. It was actually those different progressions that took place that gave us what we have today. And no, IBM did not invent any cell phones, or did they build any. But the computer development and advancements of technology required to build a sophisticated handheld computer, camera, messaging, telephone service really seemingly were light years away just back in the 1940s, and we're only talking 80 years ago. So something just to reflect on. International Business Machines, or IBM, it's an American multinational technology corporation headquartered in Armonk, New York, and it presently does business in 175 countries. IBM is the largest industrial research organization in the world. I doubt that too many people actually realize that. It holds over 150,000 US patents for inventions. It's quite a number. So let's rewind the clock back to the previous century and talk about how we got here. IBM was initially founded in 1911 as the Computing, Tabulating, Recording Company, or CTR as indicated in the logo, which manufactured time clocks, tabulating equipment, and measuring devices. In 1924, the company's president, Thomas J. Watson, renamed CTR to International Business Machines and soon became the leading manufacturer of punch card tabulating systems. I don't know if this looks familiar to any of you, but this used to be how we stored data on cardstock, not in electronic form. So the 1900s and 1940s was an era of electromechanical machines performing computation tasks which tabulated and counted cards like this using rollers, pawls, and punch cards for data input and data storage. Interesting fact, and something again a little unknown, but during the World War II years, IBM actually helped our country by building and producing M1 carbine rifles and airplane engine parts. Kind of cracked me up when I found that out. IBM machines were used to track 25 million displaced persons throughout Europe, and Washington, D.C. Used 5,000 IBM accounting machines to keep track of personnel, paychecks, and supplies. So additionally, IBM built the Automatic Sequence Controlled Calculator, the ASCC, during that time of World War II. And it was an electromechanical computer. 1946 gave birth to vacuum tubes. Ta-da! New way of doing stuff. So on-off switches were done through vacuum tubes, and the first computers to perform digital computation. So they weren't having to be bound to paper, right? In 1948, IBM developed the SSEC 603 and 604 computers for the University of Pennsylvania. The SSEC had more than 12,000 vacuum switches in it, or vacuum tubes. It's hard to imagine just building that many of them, and that was only one machine. And it also had 21,000 electromechanical relays. The vacuum tube-based IBM 701 was developed for Cambridge University and was offered commercially in 1952. The largest of all vacuum tube machines was called the SAGE. I don't know what SAGE stood for, but they always did funny acronyms like that.
Oh, I think we know.
Simulated automated ground environment.
Thank you very much. So that was Simulated Automated Grounding Environment. Is that correct?
That's close enough.
Okay. That was for the video. It was a computer that IBM developed in the U.S. Air Defense System. 27 of these were built, and MIT was actually running the program for monitoring real-time events. So we moved on. I think actually I should have had that slide up. This was kind of an example of tubes and resistors and capacitors that were used to make various configuration of logic modules, right? In 1956, IBM introduced the 305 RAMAC. And this was the first computer with a hard disk drive, one of the last vacuum tube computers that IBM built, and it weighed 2,000 pounds. This disk that you saw back there in the earlier page, it had 50 platters on it. They were 24 inches in diameter, and hold on to your seats, that disk contained 5 megabytes of data. Yes. And at the cost of that machine, that was $10,000 per megabyte. So not what we do today, obviously. In 1958, IBM switched to transistorized designs with the 7000 and the 1400 series computers. Working storage or main storage was initially developed in using small magnetic cores. It might be hard to see, but what we have as a picture here are all these little tiny cores that are tied together with wire, and they would be charged to either have an on or off state, right? So those were the bits of storage in each one of those little cores. The various sizes of the cores changed over time, and mainly for the aspect of speed. core storage was actually used, started in the 1950s, and it was used up into the 1970s. I mean, I worked on machines that had core storage, and I was hired in 1973. And there's another example of the core pictures. And in the one corner, that's actually a core array from an IBM Model 360 system, which did come out in the 60s. It had a whopping 64K of memory. And I'm guessing, I should have looked it up, but that core storage unit probably cost $180,000 or something. It was probably something outrageous for its time. So we moved from there to transistor technology. And there we go. Transistor development made for smaller and more reliable replacement of vacuum tubes and were 6 to 10 times faster. In 1959, transistors and capacitors would be combined on individual circuit cards like we see here, making the IBM 1401 one of the smaller and most popular computers that IBM came out with for banks and retail chains. The 1401 was still the size of 2 refrigerators, and more than 10,000 of them were produced by IBM. In the early 1960s, NASA used the IBM 7090 computer for moon flight simulation. The 7090 could perform 229,000 calculations per second, which actually sounds pretty impressive, but nothing like today. In 1961, IBM delivered the industry's most powerful computer, the Model 7030. Its nickname was Stretch, and once again, I don't know if there's anybody in the audience that would know what that means, but that was what the computer was called. Stretch had 150,000 transistors and could perform 100 billion computations in a day. In 1962, IBM completed the Sabre reservation system for American Airlines, and in that same year, just as a note, IBM introduced the highly popular and successful Selectric typewriter. I'm sure you guys probably would recognize that and that lovely little type ball. Do you remember the amazing little type ball? How fast it could rotate, tilt, and smash into the platen to imprint a character at lightning speed. Days gone by. In 1963, IBM employees and computers helped NASA track orbital flights for the Mercury astronauts. IBM continued its support of the space exploration program, participating in the 1965 Gemini flights, the 1966 Saturn flights, and the 1969 lunar mission. In 1964, we got introduced to solid logic technology that was built by IBM, nicknamed SLT. And it was a new generation of technology and the industry's first high-volume production of micro-miniature semiconductor circuits. The circuits were mounted on half-inch square ceramic modules that are actually shown here. And that was really the beginning of starting to condense our world into a small technology. And as you can see, they were about a half-inch square, so it, 10, 11 centimeters. So, on April 7th, 1964, IBM launched the first computer system, actually a system that was a family of computers called the IBM System 360. It spanned the complete range of commercial scientific applications from large to small, allowing companies for the first time to upgrade models without having to rewrite their applications. So what you're seeing here is, like in the front row, there's 5 different systems. The little guy over, to your right probably, and then all the way up to the larger models. What's lying in the back row are all the various peripherals, or I/O. I/O stood for input-output devices. Various devices, tape, DASD, printers, etc. So those were the combinations of things offered in the System 360 world that could be hooked up to your system. Next era came the integrated circuits of monolithic storage, or monolithic integrated circuitry. It was a full, IBM introduced this in 1970, and they were able to place many circuits on these tiny little silicon chips. The IBM System 370 was the first computer systems using this monolithic storage, and yes, I guess we do have a slide up there. That's where it says IBM Innovation. I don't know how, oops, it's not on your screen. Oh, that's the next one coming up, excuse me. My fault. So in the early days, mainframe computers were essential because of their processing power. Big computers, right? And in those days, they basically ran kind of one job at a time, and they were run by the person that was actually in the computer room, the operator or the programmer. So after 20 years of hardware advancement, IBM software engineers developed something they called VMOS, which was a virtual machine, and that was the operating system. The virtual machine offered hundreds of users the opportunity through terminals to connect to a single machine, and virtually they all looked like they were running their own computer, hence VM. And yet it was, cut up into pieces. As you see in this diagram, the computer operator that's in pink has got those different pieces of the machine, and the one in teal is looking at other parts of the computer system. But to them, it was all their own computer, but in reality, in the mainframe world, it was just one big system. Virtual machines shared all the system resources, as I was just talking about. Then in 1978, this was the first time, IBM was the first one actually to mass produce chips of this density. They were 64,000-bit chips. And in this drawing that you're seeing here, it's a 3 1/4 inch wafer. It looks larger than that maybe, but and it contained 109 silicon memory chips, each of them with a capacity of 8 megabits, or bytes, excuse me, 8 megabytes. So this is a trivial point, during the 1960s and 70s, the IBM mainframe was the dominant computer system exemplified by both the System 360 era and the System 370 platforms. IBM produced 80% of the computers in the US at that time, or during those years, and 70% of the computers worldwide. So our next era that we kind of embark on in the 1980s is when we were introduced to, in IBM's world, TCMs, thermal conduction modules. And you may have recalled back on the previous slide where we had the various chips on here. Well, this is an example of those chips being applied onto a large disk, and then what you're seeing there is all the silicon memory and logic chips were under spring-loaded copper heat sinks, and then the plate that you're seeing mounted on top, it would have another plate installed on top of it that actually had water cooling. So it drew the heat off of these plates. It had to have water-cooled mainframes back in the 80s and into the early 90s. So here's a backside of that thermal conduction module. Excuse me. It had over 2,000 gold connector pins. And as you could tell, those would have been very fragile. We had a tool that we had to set this thing in and place it on, and then cam it into place so as not to damage all those little tiny pins so it'd make connection for the circuits. Here's a picture of a gate that has, well, there's actually 4 gates here, but each one of the gates has 9 thermal TCMs in it, and you can see the rubber hoses that are connecting water to the plates that are drawing the heat off of those. So they ran at a pretty high temperature, so it was a necessary step of having these systems in place. The TCMs were used in the Model 3081, 3091, and the 9021 systems that IBM produced. And in this case, you can see 9 per gate, 8 gates in a machine perhaps, and 36 TCMs. And then there was a separate frame that would water cool these. So, on to the machines that I got to service personally. Over the first 20 years of my IBM career, I was trained on over 400, kind of makes me sort of sentimental about it. I was trained on over 400 different IBM products and machine types. We've looked at some of those technologies already, but I thought we'd just focus in on a few that we might not have covered and highlight those as I was in the world of working for IBM. So you remember the old card punch we talked about earlier, and this was used as data entry through the 1970s. The way that the programmers and other means of people that were doing input would make those cards was on a key punch. So here's an example of an 029 key punch and a 129 key punch. This I thought was a cute picture. I thought I would grab it. As you can tell, the lady there standing with the stack of cards, there's over 82,000 punched cards in that stack. And that would represent, at 80 columns in a card, right? So you've got a column is an actual bit of data like an A or a 3 or a B. So that represents a whole total of 6 megabytes of data. And then, of course, over here, my little SanDisk flash drive that has 256, not K, not meg, but gigabytes. So in 50 years, that's how far we've jumped. It's pretty amazing. This next slide represents some tape drives. Again, the 3420s are in the back row, and those were the round reel tapes that you always see in all the movies that make you think you're looking at a computer, when in fact, of course, this was just an input of data into the computer. Yes, sir?
Would that have been 9-track, 1,200 bits per inch?
That is correct. The 3420s were 9-track tape drives. Before that, there were actually some 7- and 8-track tape drives. There are so many different types that were made. And then in the foreground were 3480s, half the footprint and twice the density, actually. Actually, it got to the point where it was 5 times the density, but those were the 3480 tape drives. As noted there, one of them read at 1.2 million characters per second. The 3480s, 3 million characters per second. And I think I had a note here I wanted to make on this slide. The 3480s in the background, right? They would be considered slow, but they basically read so fast that they would go through the data of a 1,500-page dictionary in 13 seconds. And that was the slow stuff, right, of the day, the 1960s. So I also worked on a variety of disk systems. This is an older one, the 3330s. I was actually introduced to those when the first 6 months I was hired with IBM. They had removable disk packs, something I wasn't going to say, but I will now. We'd get in there with a machine and an oscilloscope, and we would just slightly torque and tweak these different lockdown screws to make sure that the heads were only 4 microns off the disk when it was flying around. I mean, that's how mechanical we were in those days. Kind of funny. We didn't do that now. They held 200 megabytes on each pack. And then the next picture I have here is from more of like in the 1980s, where you got 3380 disk drives, and those enclosures, they held actually only 630 megabytes per HDE, which is what you're looking at there. That whole disk enclosure, 24-inch disk with 7 platters, and it was only 630 megabytes, believe it or not. And this is in the middle of the 1980s, folks. I mean, we really just kept moving and moving with technology on making things denser and smaller and faster. I also worked on printers. The 1403 was a 1,000 line per minute printer that actually had a train of characters that spun around at high speed, and they got smacked by hammers on how they impacted the page. The IBM 4245 was a more sophisticated and smaller unit, and it did 2,000 lines per minute. And then came the mother of all printers, and it was actually one of my favorite printers to work on. Might be hard to tell, except by the stack of paper on the end of it, how big this thing was, but it was about the length of our stage. And the 3800 laser printer printed, remember we had 1,000 and 2,000 lines a minute. These guys were 13,000 and then eventually 20,000 lines per minute. I mean, you couldn't run with the paper that fast as it was coming out of the machine. Just another tidbit. we all probably have a laser printer or had one, and you know, when you remove the cartridge, you saw that little tiny spool that was about this big that had the photoconductor wrapped around it, right? The photoconductor on this had a drum that was 30 inches in diameter. So it put about 7 or 11 images on it as it was spinning around and putting that off onto the paper. It was a big beast, kind of maintenance required.
Did it text only or did you do graphics too?
Yes, the Model 3 did a variety of graphics and print and fonts, yes. Anything that you could throw toner on. I don't know, just to back up real quick, and I might have to cut something out later, but laser printing, basically, you are charging with a laser onto this photoconductive material. You're changing the charge on that photoconductor. And then as it comes around, you're taking toner, plastic, melted or ground up plastic, and throwing it onto the photoconductor, and whatever sticks is your print. So if you can take pixels and, you know, digitize them by dot by dot by dot by dot, I think it was, I forgot what the 2,000 characters or what it was, but so if you had a picture, if you had a letter, anything you could do by pixel form, that's how that took place. And while this drum was spinning around, all those processes were happening. A laser light that was coming in, I probably actually did have this written down, but dual beam lasers hitting multifaceted mirror. I think there were like 15 or 20 facets on it, spinning at 12,000 RPM, and that's what was throwing up onto the photoconductor as that drum moved around about as fast as I'm going right now. And yet it had to do it all the way across before it ever incremented the next millimeter, right, for the next print. So a pretty amazing technology.
I was going to say, aren't the patents for that originally anchored to IBM? I mean, isn't it from their patent library?
I couldn't swear to that because Xerox also had their own versions of laser printing, and IBM actually had to produce their own photoconductor that was unique and different from Xerox so that they weren't infringing on Xerox's patent. So yeah. Okay, where are we? I might move along here. So we all recognize what a check looks like, and I doubt that hardly anybody in this room even writes checks anymore. I mean, we've gotten to that point, but certainly, you know, if you're not over 40 years of age, you probably didn't even start using checks because everything was so electronic. But the point is that before we could get there, we used to write and have to process checks, and it took big pieces of equipment to do that. Checks were a commonplace of anybody making, you know, paying a bill, going to the grocery store, etc. What people probably didn't realize, though, it was a huge overhead to banks. They had to put a big infrastructure in place to process these checks and to report them to the Federal Reserve, and then to even return them to you, the check writer, because in those days, people wanted their checks back for tax purposes or what have you. So to give a little background, checks use a special magnetic ink on the bottom of them, which is what the picture is kind of for, that line at the bottom, for bank accounting and the bank routing number, accounting number, and eventually the dollar amount, which got put on at a later point in time. And this is called micker. It's a magnetic encoded line of data that's on the bottom of your check. Every check had to run through a machine of some kind a minimum of 5 times before the processing was done. And 4 of those times probably went through a 3890 check sorter. A couple other times maybe some other equipment. But we're getting to what I really want to talk about, and that is this gigantic beast of a machine called an IBM 3890. And the 3890 was a high-speed document processor. It was introduced in 1973, and it used to read and process and sort checks. Since it came out in the 70s, it was using some of that technology we talked about, MST and SLT logic, but it was also very mechanical. But it was also very electronic because it had to keep track of everything it was doing, and you'll find out why in just a minute. It was developed by Charlotte, North Carolina, or by IBM in Charlotte, North Carolina, but it was produced by IBM in Endicott, New York. I think I would have rather stayed in Charlotte personally. Anyways. Another view of the document processor. The IBM was used by financial institutions to capture the information and sort the checks, reading that Micker line that we talked about before. The check code line was read into a software program. So as it went through the machine, it read that line, and from that, the sort program would determine what pocket it was going to send it to in this line of machine. And you'll appreciate a few more things about this in a minute. These are a couple of the feed modules, and the module on your left, it had to basically separate those checks, feed it, magnetize it, read it, send it up and endorse it, and then send it on its way down the transport. You remember how long the machine was, 60 feet or 50 feet? It's doing this 40 checks a second. Okay, and in the time that it got fed, where you're seeing it, to the time that it got halfway into a couple of these modules, the program had to already know where it was going to send it, because it couldn't wait until it got down into the stacker, because by then it's going to be past the pocket, right? So there's processes happening here that are extremely fast, and guess what? That sort program might have been 30, 100 miles away at a data center where the central processor was processing and working with this machine. Kind of impressive. Anyways, what slide are we on to? 46. So we already described a little bit about the left feed, right feed. We also have an image module. This was not developed until about 10 years later into the lifespan of a 3890, because they used to put everything on microfilm. Some of you might remember what microfilm was, but it's basically taking a picture on film, right? Well, now we want digital images. So this was an enhancement. We had to pull a module out, put a module in, and it was capturing it just like your scanner at home. Your scanner that catches the 8.5:11 photograph in about 3 seconds. This was taking a picture of the front and the back of the picture. That's how fast the check went by. And it did it at a quality image better than your scanner at home. It was pretty impressive. It took 5 PCs to spread that data across to capture all that data that quickly. It was quite a mechanical and electronic marvel. Anyhow, this is one of the stackers that you remember seeing in that long line of modules, or there were 6 of these down there. And each module or each stacker has 6 pockets. And in that transport that's being handled, you know, the document running at 30 miles an hour or whatever it's doing, these levers, as the document's going by at 30 miles an hour, and they're only this far apart, it's flipping and closing, flipping and closing, flipping and closing, and letting checks land in different pockets. And it didn't, you know, miss a beat. So it was pretty impressive. So there was a lot of electronics and air system that kept track of where the check was and how it controlled that function. Again, this isn't necessarily the kind of computer most of us think about, but it was definitely a significant part of the process that banks did in those days. So I thought it was worth bringing to light. Here's a couple of frames that were the logic gates that controlled all the functions of the 3890 check sorter. So, you know, you've got boards with cards plugged into them, control programs in there, the mechanics that running the selector blades and running the, you know, the various mechanics of the machine are all being controlled with this logic. Each board could plug 20 cards into it, and you know, just a quick picture of, you know, what this machine, and that's a 3890, and that's how we did it back in those days. It had a dominant presence in the banking world for 23 years. Once things started going to imaging and digital, especially with 9/11 when that took place, it was more important for digital records to be kept than it was the paper records. And it was actually the federal government and the Federal Reserve that was requiring all of the paper be kept of checks. And once 9/11 happened, that door busted wide open because we had a major problem with the World Trade Center and various things that got destroyed. So the imaging that IBM was already doing as check sorters 10 years prior now became a real factor in the banking community. So I'm going to blank that out for a minute. So we're going to jump into the IBM personal computer history. Looks like I have about 10 minutes, maybe less, so I'm going to whisk through this maybe kind of quickly. Matter of fact, I'm going to go ahead and skip the intro and just talk a little bit about floppy disk, which were part of the PC world. There's a lot about IBM's history that, with the PCs, that is kind of interesting. They were not the first to get in the game, but and they were probably one of the first to leave the game. But they actually made a big impact on the world because the IBM personal computer, when it came out in 1981, it set a standard for people, and it became one of the most influential personal computers for a decade. They didn't necessarily market themselves very well and do things because they were used to commercial world and not the consumer world. But as an example, in 1983, IBM sold 750,000 personal computers. But I want to move on to just talk a little bit about some of the pieces of what make up PC. And the diskette evolution was something kind of interesting. The floppy disk drive, which was called a 23FD from an engineering standpoint, it was invented at IBM in 1967. And it used the 8-inch floppy drives, which of course we weren't exposed to in personal computers, but that's what commercial system applications used. The 3890 we talked about, I booted my diagnostics off of this 8-inch diskette. That's, was one of the tools we had for it. In 1973, that got improved and was called the 33FD by the wonderful engineers, but they also gave it a code name. It was called, and most systems in those days, they were always coming up with acronyms and code names, for Maverick and what have you. But the 33FD was called an IGAR. Does anybody have a guess at what IGAR stood for? What, my front guy down here that's got all the background? It's sillier than you think. It goes around. And I'm not kidding, those words were actually printed on the logic diagrams that I would use to sometimes service these things. So the engineers actually did give it the name. It's kind of funny. In 1976, the diskette evolved into a 5 1/4, which is the middle one that you're seeing here. And the 5 1/4-inch diskettes were the first ones used in most personal computers. That format was eventually replaced with a 3.5 hard shell, which we all really probably became more familiar with. And there were 3 generations, not only of the diskettes, but 3 generations of formats. We had the 360 KB diskettes, the 720 KB, and then eventually the 1.4 megabyte. And we were all ecstatic when we could get a 1.4 diskette. The funny thing is, when they first came out in 1987, a box of 10 cost $96. It was like crazy expensive, just funny, anyhow. So let's just take a quick look at the 24-year history of IBM personal computers. And I'm running close on time, so I'm not going to read every one of them, but it looks like they're readable for you, probably unless you're way in the back. But, we came out with the 5150 in 1981. The portable, that was a funny one in 1984. That weighed, well, we'll get to it. It was a 30-pound luggable. That's what we called it. We had the PC convertible in 86. That was actually a cute machine. And then in 1992, the one I loved forever, the ThinkPad. The ThinkPad was around for like 20-some years, and it was actually one of the best laptops, I think, that was on the market. So I'm going to go ahead and move forward. We're just going to highlight a few of these individually. So this was the first IBM PC in 1981. It ran basic PC-DOS. That was it. Did not have a hard drive, of course. Used the cheaper Intel 8088 because they didn't want to spend the money on the next level Intel chip. And it had 16K of memory. I guess you could expand it to 256K. We're not there to a meg yet, right? So then here's that lovable luggable I was talking about. I mean, this thing, that was their portable personal computer, their first go at it. I saw a few Commodores out there in the viewing area that looked something like that. Again, 8088 Intel chip, and 256K of memory, no hard drive, just 2 floppy drives. We moved up to the PCAT in 1984. It had 256 KB on board of memory, but it could expand up to 4 megabytes. Hey, that's hot stuff. And it had a 20 megabyte hard drive. Can you imagine only having a 20 megabyte hard drive? I mean, I don't know. There's probably some programs that you can't even load into that solid space nowadays. But anyways, it also still had floppy drives available to it. This was a cute little device. This was our first laptop at home. My daughters did their homework on it, 1986. It weighed 12 pounds, the IBM PC convertible. No hard drive, just you did one diskette was your boot of your DOS. I don't know if it ran 3.1 or not. I don't think it ran Windows on there. And then the other diskette was what you could do your data work on or install or load your word processor on or whatever. So cute and affordable and impractical today. PS2. I don't know if any of you have really even seen these types of towers. They're much narrower than the normal towers we would see for years and years in the PC world, but they abandoned the 5 1/4 diskette drives, so they thought they'd make these things to fit just a 3.5, which is what the picture shows. And this was also the introduction of IBM's departure from the normal PC world. They wanted to introduce microchannel to the world. And microchannel was completely different than the normal buses that we had in those days of 8 and 16-bit. It was a 32-bit bus, both to the processor and to the memory. And it was 10 years ahead of its time, unfortunately. Windows wouldn't embrace it. Bill Gates had already departed from IBM. He used to write code for IBM, by the way. And the microchannel was just enough of an odd duck that all it really became popular is with internal IBM. So all the IBM offices, all of our tools, everything used microchannel machines. But that was the PS2. Then the lovable ThinkPad, which I still own 2 of them today. Gosh, I think mine are 10 years old. They still work like a champ. I do have my HP with me, though. I'm not partial. And it had the patented track point mouse. I don't know if any of you use them. It's the little red eraser in the middle. Some people hated them, and I loved it because I didn't have to have a mouse with me. And I couldn't stand the pad in the front where my palms were on it, and every time I moved my hands, it was hitting an enter key or doing something crazy. So the track point was my way to use a laptop. But not everybody embraced it, so only IBM. And actually, believe it or not, Dell, and I think maybe even HP, their business versions, once the licensing or patent was over or whatever, they incorporated it on their laptops as well. Or maybe they bought the license from IBM, I don't know. So anyways, track point. It just took a little finger, not a big deal. And then one of the other last models that I wanted to display was an IBM Aptiva. It came out in 1994. It was, again, more of a standard. It did not use microchannel. It was a standard, PC. And I think there was just another point I was going to make. Had to do along with, well, if I already missed it, I think it was back on a feature slide, but IBM stopped producing PCs in 2005. They sold the business to Lenovo. You probably saw that on the one slide. I kind of skipped by it. And the main reason was that it didn't meet the criteria that, and this is going to sound terrible, I really am a true blue IBMer, don't work for them anymore, but it didn't meet their certain criteria, and that's the way they did all of their equipment, from tape drives, disk drives, printers, whatever. They always expected to make an 18 to 20% profit margin on their equipment, and when it started going and going below that, they just decided they didn't want to be in that business anymore. And frankly, they didn't know how to market to it. That was really their biggest problem. And there's, I could spend 20 minutes talking about why, because it's really kind of an interesting background. But if you want to get that answered, you can meet me out in the meet and greet at 2 p.m. that my niece has me scheduled for. And we can talk a little bit about that. So that's my pitch on IBM, how it affected or influenced the technology we have today in the world of computing and in all the conveniences that we experience. We can really thank the guys back there in the last 50 years of the previous century. Thank you very much for your time.